Hey everyone, this is Mr. K, and today we're going to go over the second part of the Precalculus summer homework. So the second part is simplifying radicals or simplifying square roots. I'm going to show you two different ways of doing this. One's the long way, one's the short way. So I'll start with the long way. Looking at the work here, we have the square root of 80. Instead of having to worry about perfect squares, which may be one way you were taught, another way of doing this is just what multiplies to 80. So my first thought was I could do the square root of 10 and the square root of 8. And what we're going to do is we're going to keep breaking this down as far as it can go. It's called prime factorization. So I'm going to break this down further into the square root of 5 and the square root of 2. And now 5 and 2, I can't go any further. Like, they are as broken down as they're going to get. So looking at 8, I would do the square root of 4 and the square root of 2. And then 4 I could break down into the square root of 2 and square root of 2. And so now once we break down the radicals or the square roots as far as we can go, what you're doing is you're looking for pairs. And pairs are going to go out in front of the radical, and then anything that's left over is going to go inside the radicals. So like here, I have a pair of square root of 2's. I have another pair of square root of 2's, and so that number is going to go out in front, but it's going to go out twice because I have two pairs. So I'm going to write like a 2 for the first pair, 2 for the second pair, and then this square root of 5 is left over, so that's going to go underneath the radical. And now the last thing we have to do is, what is 2 times 2? It's 4, so we'd have 4 square root of 5, and that would be our simplified answer. The other way you can do this, and it's, I believe, more difficult but faster, is you can find the perfect square that goes into that number, like the largest perfect square. It needs to be the largest one. So for example, when I see the next problem here, which is the square root of 648, I personally know that the 18 squared is 324, which is half of that, so I could break this down into the square root of 324 and then the square root of 2. But the square root of 324 is nice, it's 18, and I can show you. Got my calculator here, and I can do the square root of 324. I get 18, and then if I just do 324 times 2 just to prove that, yep, that equals 648. So I can rewrite this second problem here as 18 square root of 2. So either way works. I think the first way is longer, but it's easier to do. Second way is more difficult, but faster. So problem number 3 here, when you have a number out in front, just kind of ignore it to start and just simplify the radical as is, and then multiply by 5 at the end. So like when I look at this, I'm going to take the short way here. I would do the square root of 25 and the square root of 7. So this would be 5 times the square root of 7. However, since we had this 5, that kind of like comes along for the ride here. And so I'm going to multiply that by 5 as well. And then I can do 5 times 5 is 25, and then radical 7. And that would be our answer. So, again, either way works. So for the next problem here, I'll show you the long way. So I would break this down into the square root of 24 and the square root of 2. But then that breaks down into 6 and 4, and then 6 breaks down into 3 and 2. 4 breaks down into 2 and 2, and so now if I look, I got a pair of 2's here, I got another pair of 2's here, and this 3 is kind of like left over by itself. I also have this 3 that was out in front, so I'm going to start with the 3 that was out in front times my first pair of 2's times my second pair of 2's, and then a 3 goes underneath the radical. And so 3 times 2 times 2 is 12, so this would be 12 square root of 3. And then the last one, it's just, honestly, it's kind of a trick question. So the square root of 36 is nice. That's just 6. So it's 7 times 6, which is 42. One other thing to kind of, as an example for this last one here, let's say that we also had a spare, let's say, square root of 5 hanging out here. Like, what would you do with that? If the 5 was by itself and this 3 was also by itself, then it would be underneath the radical, you'd have 3 times 5, so this would be like 12 square root of 15. I know I just changed the problem there, but that's how you would handle it if you had more than one radical that was by itself. I hope you found this video helpful. Leave any comments with any questions you might have, and hope you have a great day.